Today we're putting Claude Code, OpenAI's Codex, and Qwen 3.5 running locally through the ultimate creative gauntlet, using the Blender MCP to build 3D models from nothing but text prompts. Before we get to the good stuff, let me show you how to actually wire this up. All three of these AIs connect to Blender through something called the Model Context Protocol, or MCP. It's basically a bridge that lets an AI send Python commands directly into Blender in real time. The Blender side is the same for all three. You download the add-on from the Blender MCP GitHub repo, go to Edit, Preferences, Add-ons, click Install from Disk, select the add-on file, and enable it. Then press N in the 3D viewport to open the side panel, find Blender MCP, and hit Start MCP Server. That opens a socket on port 9876, and Blender just sits there waiting for instructions. Now here's where each AI differs. For Claude Code, you're working in the desktop app. Go to Settings, then Developer, then Edit Config, and you'll see the Claude Desktop Config JSON file. You add a Blender entry under MCP servers with the command set to UVX and the argument Blender MCP, save that, restart Claude. The Blender tools are loaded and ready. For Codex, you're also in a desktop app. You go to Settings, then click on MCP Servers, add server, and enter UVX as the command to launch, Blender-MCP as the argument, and the working directory. My working directory, for example, is on my desktop in a folder called Codex Blender. Once it's configured, Codex picks up the Blender tools automatically when you start a session. And then there's our local contender. For Qwen 3.5 running in LM Studio, you go to the Developer tab in the sidebar, click mcp.json, you add a Blender entry just like the others, command uvx, args blender-mcp, save it, restart LM Studio, and the tools should show up when you start a chat. Alright, everything's wired up. Let's see what these AIs can actually do. But before we get into it, if you found this video helpful so far, stretch that little thumb of yours to click that subscribe button and help us get to 100,000 subscribers by the end of this year. Alright, now let's get into it. We're starting with the classic Blender beginner project, the donut. Here's the exact prompt all three received. I want you to make a 3D donut using the Blender MCP. I want you to go above and beyond, be creative. You will be graded on the visual appeal of your result. Same prompt, same tools, let's see how they think. Codex took a methodical, almost cinematic approach. It started by inspecting the scene and available integrations before writing a single line. Then it built the donut with custom geometry for both the dough and the glaze, hand-tuned icing drips, sprinkles, crumbs, a ceramic plate, and a soft studio backdrop. Where Codex really stood out was its iterative process. It rendered a hero frame, saw the camera was too tight, measured the donut's framing mathematically, widened the lens, re-rendered, noticed the glaze was reading too soft, carved the icing back from the center to reveal the donut hole more clearly, adjusted exposure, rebalanced colors, and kept going. It treated the whole thing like a real product photography shoot with multiple art direction passes. Claude immediately mapped out a plan. It cleared the scene, built a torus for the base, then sculpted a separate icing layer with realistic drip edges. What impressed me here is it didn't just stop at one donut. It decided on its own to add a second chocolate donut leaning against the first for a more interesting composition. It scattered sprinkles using a particle system with 7 different candy colors, added a bite taken out of the front donut with crumbs nearby, and built a warm marble table surface with a full 3-point lighting rig. The final scene had subsurface scattering on the dough for that soft bread-like translucency, glossy icing, depth of field at f3.2, and was rendered with cycles using AGX color management. Claude basically art-directed an entire food photography shoot. Up next is Qwen. In case anyone is wondering, this is Qwen 3.5 122 billion mixture of experts model, 4-bit quantized. I'm running it on the new MacBook M5 Max with a 40-core GPU and 128 gigabytes of unified memory. I have to admit, I was surprised that I was able to run this monster of a model alongside Blender at all. Qwen took about 8 minutes to complete a masterpiece of a donut that is safe and local on this device, so I don't have to worry about any big company stealing this beauty. This is the result from Qwen. We can safely say that Qwen wins this round. Next up, a character recreation. I gave each AI a reference image of the Claudebot logo. Codex studied the reference carefully and made a deliberate design choice. It kept the silhouette faithful and pushed the 3D appeal through richer materials and a polished product shot presentation rather than overcomplicating the shape. It rendered 2 separate outputs, a faithful front view and a wider beauty shot from a hero angle. Where it struggled was getting the specular highlights under control. The body was blowing out hot in early passes, but it self-corrected, dialed the lighting and material gloss back, and delivered clean final renders. Claude analyzed the image, identified every feature, and built the whole thing from primitives. It added subsurface scattering on the body for that soft, plush toy feel, emission shaders on the teal pupils so they actually glow, noise texture for material variation, cute cheek blush spots, a dark reflective pedestal with glowing teal rings around the base, and 12 floating luminous orbs scattered around the character like magical particles. The thing looked like a collectible figure you'd buy at a convention. Now let's talk about Qwen's Claudebot. Qwen created a masterpiece in record time. The finished product genuinely stopped me in my tracks. What you're seeing here is not just a 3D model, it's a beautiful piece of art that really touches the soul. The attention to detail is immeasurable. Qwen takes the dub in this match again, and it's not even close. Now things get serious. I handed each AI an image of the UFC World Championship belt. Codex pulled the main design language from the reference. The layered octagonal center plate, black leather strap, gold and silver trim, inset black enamel, and the raised UFC word mark. It fought with the lighting. The metal was reading too flat and the center was washing out, so it pulled a studio HDRI into the scene for real reflections, did a darker studio setup, and rendered both a close hero shot and a wider companion shot. The result was impressive. It went for a photorealistic cinematic shot, and I really like how it used the white and red lights for contrast. Claude went absolutely wild on this one. It built over 100 individual objects, a 5-layer central octagonal plate, 7 decorative horizontal bars, 2 side plates with 4 layered octagons each, a full-length leather strap with realistic tapering, gold edge trim curves, 56 gold studs, corner accent spheres, decorative plate rivets, stitching detail, and buckle end caps, 6 custom PBR materials, and 6 lights. The render came out looking like something from a promotional shoot. It had to fight some lighting issues. The chrome borders kept catching too much light and blowing out the center, but it iterated through multiple passes, repositioned the key light, adjusted material roughness, and eventually nailed it. I need everyone to sit down for this one. Qwen's UFC belt, which it finished in just 5 minutes, is a statement piece. What we're looking at here is a deconstructed interpretation of championship glory, and I'm not being dramatic when I say this might be the most artistically bold take any AI has ever produced. It was close when judging these results, but Qwen once again takes the dub, leaving the competition in the dust. Next, a classic, the Pokeball. Red top, white bottom, black band, center button. Simple geometry, but the materials and presentation separate the amateurs from the pros. Codex had a rougher journey here. It built the geometry cleanly and set up good materials, but then it hit a real bug. The red top shell was rendering white. It spent several iterations diagnosing the problem, eventually discovering that the Boolean operations had left an empty material slot at index 0, and every face was pointing at that empty slot instead of the red material. It tracked it down, rebuilt the material assignments, and recovered. The final result included a floating display pedestal and a soft halo accent. This was a great example of Codex's debugging persistence. Most humans would have rage quit Blender by that point. Claude built a high poly sphere with 128 segments, separated it into top and bottom hemispheres, added a torus-based equator band, and constructed a multi-part center button with a black outer ring, white ring, raised center cylinder, and dome cap. The materials were dialed in, rich crimson with clear coat, bright white with high specularity, deep matte black, and extra glossy white for the button. Then it went creative. 15 floating glowing energy particles, a subtle blue point light inside the button for inner glow, a dark reflective ground plane, and a 6-light setup that made the final render look like a premium product shot. Of course, Qwen had to come in and take it to a whole other level. It came in, slapped this beauty together, dropped the mic on everyone, and walked away. The confidence is well deserved, and if I had to pick a Pokeball to catch a Pokemon, it would definitely be this one. That's another point on the board for Qwen. And now, the final boss. A full fantasy dragon with golden brown scales, bat-like wings spread wide, glowing ice blue spines along the neck and back, luminous blue-purple horns, muscular legs, and a long tail. This is where we separate the contenders from the pretenders. Codex took a completely different approach here. Instead of building from primitives, it tried to use Hyper 3D, an AI model generation integration, to generate a base mesh from the reference image. When that failed on the image encoding, it pivoted to a text to 3D prompt, generated 3 different candidates, evaluated each one, and picked the best. Then it did a controlled deformation pass to get the proportions closer to the reference, stretching the torso, lifting the neck, sweeping the wings back. It added custom horns, icy dorsal crystals, and a color correction layer over the generator's original textures. The final result is more of a stylized interpretation than a faithful recreation, but the process showed something interesting. Codex will actively leverage external AI tools and iterate across multiple generation passes rather than brute forcing everything from code. Claude built this beast from scratch using over 80 individual objects. It started with the torso, added 4 muscular legs with 12 claws across all 4 feet, constructed a long tapered tail, and built massive bat-like wings with 4 finger bones per wing plus the main arm bone. The head got horns, glowing eyes, and a jaw structure. Then came the signature feature, 49 ice spines along the neck, back, and tail, all with emissive blue glow shaders, plus 10 ice crystals clustered around the horn bases, 6 custom materials, 5 dramatic lights including 2 blue accent lights that created a beautiful ice blue pool of reflection on the dark floor beneath the dragon. The final composition genuinely looked like concept art for a fantasy game. And now, the moment you've all been waiting for. In only 5 minutes, Qwen was able to create an exact replica of the dragon image. Even though it is obvious that Qwen won this entire match, I want you to comment down below who you think won each of the 5 rounds. And don't forget to like and subscribe for more videos like this. I'll see you on the next one.